this is Miss Redmond here today. I hope you guys are well. So we're going to be looking at lesson 1.5, and the learning target for today is I can add and subtract rational numbers. So to start for the warm-up, I'm going to ask that you combine 3 and -2. You could go ahead and use whatever method you like. So there is 2 main ways you could approach this problem. You can write combine 3 and -2 either as an expression as a 3 plus -2, or an expression that says -2 plus 3. Remember, combine means add, but the order doesn't matter for addition, and that's because of the commutative property of addition. So let's go ahead and look at 3 plus -2 first. We can rewrite this simply as 3 minus 2. Now this you guys all know how to do. Here we just get 1. For our other example, -2 plus 3, because we have a negative number plus a positive number, we have to subtract those. So we're going to take 3 minus 2, because when we subtract, when we find the difference between two numbers, the bigger number has to go first. So we get 3 minus 2, and here we get 1. Oh, my pen turned off. Notice this is exactly what we did here. But we're not quite done with the process when we're adding a negative and a positive number. We have to go one step further and ask ourselves, is this one positive or negative? And here our answer is going to be positive because the 3 is a bigger in value, absolute value, than the -2. So here our answer is positive 1, or just 1. So the second process requires an additional step when we add a positive and a negative, but if we can just turn our addition into subtraction, it makes our lives a little bit easier because we have the simple expression which we already know how to do. So let's look at a problem from your workbook. This is example 1.2, lesson 1.5, example 2. My bad. This is example 2 from lesson 1.5. So this says the force of gravity added to the force of thrust is the combined force at work on a model rocket. What is the combined force in newtons on the rocket? So you can see we have a thrust of 1.5 newtons up, and then -0.49 newtons because of the gravity. So we have that negative because that's a thrust down. Gravity is pulling that rocket down towards the earth. However, because of the thrust upward, it's still able to move upward. If we compare 1.5 or 1.5 to -0.49, we can see that 1.5 is greater than 0.49 if we're just looking at those absolute values. So we know our rocket is moving upward. It's not dropping yet, right? So we're going to write expression for our word problem here. It said that the force of the thrust force of thrust added to the force of gravity is equal to the combined force at work on the model rocket. So I'm going to say is equal to the combined force. The combined force is what we're looking for. Okay, so we need to plug in what we know into our equation here. So the force of thrust, we have 1.5 plus the force of gravity, which is negative 0.49. Let me write that differently. So there, that looks more like a 4. Negative 0.49. So just in our last problem, we can write this expression with a positive plus the negative, or we can write this as negative 0.49 plus 1.5. Oops, wrong marker. 1.5. So you can write it either way. You can eventually get there. But I'm going to focus on the first expression, 1.5 plus negative 0.49, because we can rewrite this as subtraction. And that just makes our lives a little bit easier, as we saw in the warm-up. So from here, we can do this two ways. So we can either keep the fractions and convert negative 0.49 to a fraction as well, or we can keep our decimal 0.49 and convert the fraction to a decimal as well. So, or we can use decimals. So it's up to you. You can get the right answer from either method, but let's look at fractions first. So we need to rewrite 1.5, that mixed number, as a proper fraction. And when we do that, we get 3/2. Now 0.49 is 49 hundredths, is the way we're used to saying that. Remember, the 4 is in the tens place, the 9 is in the hundredths place. So 49 hundredths is 49 over 100. Okay, our common denominator here is going to be 100. So in order to make 3/2 have a common denominator of 100, we have to multiply the numerator and denominator by 50. 2 times 50, we get 100. And so when we do that for the numerator as well, 3 times 50, we get 150. So now I can plug this back into my equation. So 3/2 is equal to 150 divided by 100 minus 49 minus 100. So now we can complete the subtraction just as we normally would. We subtract what's on top, leave the denominator the same. 150 minus 49, we get 101 divided by 100. If we rewrite this as our mixed number, this is equal to 1 and 1 100ths, which is equal to 1.01, because again this 1 is in that hundredths place. So if we look at decimals, we can convert the 1.5 now to decimals. So a half, remember, it's 0.5, so we have 1.5, we have 1.5 minus 0.49. We can write this as Well, actually, let's just work this out. So let's work out 0.50 minus 0.49. So here we can do 0 minus 9, but we have to borrow. So that becomes 4. 10 minus 9, we get 1. 4 minus 4, we get 0. And then we have that 1 remaining. So our answer here is 1.01. So here we've completed this operation 2 different ways. One with fractions, one with decimals. Notice our answer is the same. Oops, let's get this out of the way. Our answer here is the same. So it doesn't matter what method you use. You can use fractions or decimals. It's just personal preference. A lot of times the problem will hint at it. If you see everything's already given to you as fractions, keep it as a fraction. If you already see everything's given to you as a decimal, keep it as a decimal. If it asks for fractions or decimal, obviously you want to do that. Here, usually when we work with newtons, we're going to use decimals. So here, it says, what is the combined force in newtons on the rocket? Well, we need to add in the unit there, but we get 1.01 newtons. So that's how, with how much force this rock is going upward after gravity has kind of pulled it down some. All right, so now please complete the try it problems in your workbook, and then we'll go over it together. All right, we're going to look first at A, negative 2.5 plus negative 5 and 6/10. So here we'll do the decimal way first and then the fraction way. When we're working with decimals, we're going to have negative 2.5 minus 5.6. 6/10 is 0.6. Now here we have a negative minus a negative. So remember, we have to add those and then make our final answer negative. So if we take 2.5 plus 5.6, hopefully you're going to work this out, but I'm just going to give you the answer here. And we are going to get 8.1. And then because we have two negatives, our final answer is going to be negative 8.1. If we convert this to fractions, we can rewrite negative 2.5 as negative 2 and 5/10. I'm going to write this in tenths because our second fraction there is already in tenths. And then we're going to say minus 5 and 6/10. Now, in order to subtract fractions, I have to convert this to improper fractions. So here I'm going to get negative 25 tenths minus negative 56 tenths. So now this is simply subtracting integers, and maybe not so simply. We have a negative and negative here, so I need to add 25 plus 56, and then I'm going to make that sum negative. So 25 plus 56, we get 81. And here we have a negative 81 because those two integers are negative. Divide by 10. And we're going to want to rewrite that as a mixed number. And when we do that here, we're going to get negative 8 and 1/10. Negative 8 and 1/10. I'm running out of room, but you guys know that's 10. Okay? Looking at this next one, we're first going to do the decimals, and then we could do the fractions. So we have negative 4.4 minus, and notice here we have a negative and another negative. So I'm going to make this positives. Two negatives make a positive. So I'm going to go ahead here and write plus 1.5. So when we do this, we have a negative and a positive, so I have to find that difference. So we take 4.4 minus 1.5, and this is equal to, let's see, actually, let's work this out together. So 4.4 minus 1.5. Alright, this is the work you should be doing on your own paper. We are going to have to borrow in order to take 4 minus 5, so this becomes 3. We have 14 minus 5, we have 9. 3 minus 1, we get 2. So we get 2.9 here. And again, when we add the negative and the positive, we have to take the sign of whichever one's bigger. Negative 4.4 here is bigger, so we're going to take that negative sign from it. So we have negative 2.9. Looking at using fractions, we have negative 4, and we could write 0.4 a few different ways. We could write it as 4/10, right? This is 0.4 is 4/10. So we could write 4/10. Or we could write this as 2/5 as well. So whatever you like. I'm going to write it as 4/10 for simplicity's sake. And we have plus 1.5. Now I have to convert these to improper fractions. So I have 10 times 4 is 40 plus the 4, I get 44/10. Plus 1.5, we have 3/2. Now these have to have a common denominator. So I need to rewrite 3/2 with a denominator of 10. So I'm going to do some side work here. In order to do that, I have to multiply my numerator and denominator by 5, right? 2 times 5, I get 10, and 3 times 5, I get 15. Okay, so we can rewrite this as negative 44/10 plus 15/10. And when we do this, we get, let's see, Well, we have to add across the numerator. And we get negative 29 tenths. Okay, so negative 44 plus 15, we take the difference. 44 minus 15, we get 29. Notice the negative 44 is bigger than 15, so we have to take the negative from the 44 to make that negative 29 tenths. And when we rewrite this as a mixed number, this is negative 2 and 9 tenths. Notice our answers here are equivalent. Negative 2.9 and negative 2 and 9 tenths are the same. Alright, and then this last one is for you to try.